I'm going to go over the topics we discussed in Module 8 to help you prepare for the Module 8 test. So for the first 4 problems, we're going to use the data set 13, 6, 4, 2, 2, 3, and 6 and answer the questions. So on problem 1, we want to find the median. So the median is the middle, and in order to find that, we have to list our numbers in order from biggest to smallest. So 2, 2, 3, 4, 6, 13, 16. And then we're going to start crossing them off from the ends. And because we have an odd number, we're going to be left with one number for the median. So our median is going to be 4. Number 2, we want to find the mean. So the mean is the average. So we're going to add up all of our numbers. So 13 plus 6 plus 4 plus 2 plus 2 plus 3 plus 16 and divide by the total number we have, which is 7. When we add every number in the numerator, we get 46 over 7, which ends up being 6.57. Okay. Number 3, we want to find the standard deviation. So remember, the standard deviation formula is the square root of the sum of x minus x bar squared all over n minus 1. So I'm going to start by listing all of the values x in our data set. So 2, 2, 3, 4, 6, 13, 16. They do not have to be in numerical order. I just went ahead and did that since I put them in order to calculate the median. My next column is going to be x bar, which is the mean. So the mean is 6.57 for all of our values. Next, I'm going to take each value, subtract the mean from it, and square it. And as long as you do this in parentheses with the squared on the outside, you'll get the number. So in parentheses, 2 minus 6.57, and then squared is going to give us 20.8849, which we're going to get twice because we have 2 2's. Then I do the same thing for 3, and we get 12.7449, and then working my way through all the values, 6.6049, 0.3249, 41.3449, and lastly 88.9249. So next I want to add all of these values together. So underneath the square root, my numerator is going to be what I get when I add those all together, which is 191.7143, and I want to divide by n minus 1, so in this case that's 7 minus 1. So in the calculator, we're going to have the square root of 191.7143 divided by 6, which is going to give us 5.65. Make sure on Classroom, if you don't have access to a calculator, you're using that Desmos Scientific Calculator link. It is on the classwork page at the very, very top. There is a link for you guys to use to help you with all of the math calculations for mean and standard deviation. Okay. Number 4 says if we add an outlier to the data set, say 75, what statistical value changes the most? Show your work. So I'm going to start with the median, since that's what we did in number 1. So the median is pretty much going to be the same list But now at the end, we're going to add 75. So I'm going to still cross off my numbers one by one, but because I now have an even number of data, I end up with 4 and 6 left over. So now to find the median, I have to find the number in the middle of 4 and 6. So I have to do 4 plus 6 divided by 2, which is going to give us 5 for the median. So my median only changed from 4 to 5. Medians are not heavily impacted by outliers. Since an outlier would be something very small or very large, it's going to be the first thing to get crossed off when you're calculating the median. So outliers do not heavily impact median. Now let's take a look at the mean. So basically what's going to change is instead of having 46 over 7, we want to take our sum 46, we want to add the 75 to it, and then instead of dividing by 7, we're now going to divide by 8 since we now have 8 numbers. 46 plus 75 is going to give us 121 all over 8, which is then going to become 15.125. So if we're comparing our means went from 6.57 to 15.125, which is more than double the original mean we had. So I would definitely say that mean is heavily impacted by outliers. Our last statistic we want to look at is standard deviation. Now, I'm not going to go through the recalculating. All you have to really do, because we have to go through and redo the x minus x bar squared since we have a new mean, and we have to recalculate all of our other values. So I did this already, and when we do that, our sum is 4,288.875. N minus 1 has also changed to 8 minus 1 instead of 7. When we do this in a calculator, we're going to get 24.75. So our standard deviation went from 5.65 to 24.75, which is almost 4 times as large as it was before. So I can also say that standard deviation was also heavily impacted. So if we're talking about all of our statistical values that we've talked about, mean, median, mode even, standard deviation, mean and standard deviation are impacted greatly by outliers. So now it did take about values that changed the most, not just values that changed, because the median did change, but it didn't change by a lot. So the 2 statistical values that changed the most based on outliers are the mean and standard deviation. So next we're going to take a look at correlation coefficient. So for 5 and 6, you're going to want to use Desmos, and you're going to put each table in. So we're going to go to Desmos, and in order to insert a table, we want to use that plus button in the top left. And then once you have your table inserted on a separate line, you want to type the equation y1, then our squiggle mx1 plus b. That line actually tells us what the correlation coefficient is. We can describe the relationship between the values without the correlation coefficient, but the number itself gives us more specific data. So if I take my table in 5 and I insert it in Desmos, then we, on a separate line, type that y1 with the approximate mx1 plus b. we'll have all of our data. We want to look specifically for R. And when we look for R, we get R equals negative 0.8928. So R tells us the information about our correlation without having to look at the graph. So the closer our value is to 1 or negative 1, the stronger the relationship. So negative 0.8928 is pretty close to 1. So I would say this is a strong relationship. And then because it's a negative, it's strong and negative. If we would have had a positive 0.8928, it would have been strong and positive. We're going to do the same thing for number 6. We're going to, you don't have to delete your table. You can just erase your values for X and Y and input the new unit price and units sold, and it will automatically update the formula for the Y1 approximate MX1 plus B. So once you input all of the data for number 6, we're going to get R equals negative 0.9615. So R is even stronger here because it's even closer to 1. And it is still negative, so strong and negative. I had a lot of people that when we had problems similar to 5 and 6 on the quiz, they didn't actually give me R, they just described the correlation. So make sure you're paying attention to whether or not I want both R and the description, or one or the other. So make sure you're reading the problem in its entirety before you're answering. Okay. So for 7 through 10, we're going to use our spinner to find our probabilities. So first I want to figure out how many spaces we have so that it's easier to calculate our probabilities. So if I count my number of spaces, there are 12. So number 7 asks the probability of spinning a 2. So I need to figure out how many 2s are on my spinner and then put it over the total number of spaces. So the probability of spinning a 2, there are 2 spaces with a 2 on it out of the 12 total spaces. When I simplify 2 over 12, we're going to get 1/6. Next, we want to find the probability of spinning a 3. So in order to probability of spinning a 3, I count the number of spaces that have a 3, and there are 3 3s out of 12. And when we simplify 3 over 12, we're going to get 1/4. Same thing for number 9, the probability of spinning a 4. There are also 2 spaces that have a 4 on it, so 2 over 12, which we already know simplifies to 1/6. And the last problem, 10, asks the probability of spinning a number less than 5. So basically, I count up all of the spaces that have 1 through 4 on them, and those are all of my numbers less than 5. So the probability of spinning a number less than 5, it might be easier to count up the total number of spaces that have 5 and just subtract it from 12. So there are 4 spaces with a 5 on it, which means 8 out of the 12 spaces are less than 5. And when we simplify 8 over 12, we're going to get 2/3. So the last page takes a look at our section 5, which is our independent events and their formulas. So the formula for the probability of A and B, so the probability of 2 events occurring is the multiplication of the 2 events. So probability of A times the probability of B. The second formula was the probability of A or B happening. So the probability of A or B happening is the probability of A plus the probability of B minus the probability of A and B. Now, sometimes the probability of A and B might be 0, but in case there's ever a overlap, you have to subtract that from the probability. So for 11 and 12, we're rolling a 6-sided die. For 11, we want to find the probability of rolling an odd number or rolling a 3 or higher. So the probability of odd or greater than or equal to 3, we have to add our probabilities and subtract the overlap. So the probability of rolling an odd number, so of the numbers 1 through 6, 3 of them are odd, so 3 over 6, plus, now we're saying 3 or higher, which means I'm going to include 3, so the numbers that are greater than or equal to 3 are 4 of them out of 6. This is why subtracting the overlap is important, because 3/6 plus 4/6 is going to give us 7/6. And we cannot have a probability of over 100%. Probabilities are always between 0 and 1. So I have to subtract the probability that I roll an odd number and get something greater than or equal to 3 because there is overlap. So when I take 3/6 times 4/6, we're going to get 12 over 36. So we have to do 7/6 minus 12 over 36, which if we use a calculator then gives us 5/6. Which if you think about it logically makes sense. Of all of the numbers on 1 through 6, the only one that isn't an odd number or greater than or equal to 3 is the number 2. So that means 5 of my numbers are either odd or greater than or equal to 3. So 5 out of 6 numbers give me the probability I'm looking for. For number 12, we want to find the probability of rolling double 5s. So that's the same thing as the probability of rolling a 5 and rolling a 5. So this is probability of 5 and 5. So we want to multiply the probabilities together. So the probability of rolling 5 on my first roll is 1 out of 6 because there's only one number out of the 6. And these are independent events because if I roll a 5 on the first roll, that doesn't change the probability of rolling 5 on the second. So the second probability is also 1/6. And we're going to multiply straight across, and we're going to get 1 over 36. So 13 and 14 are going to use event A is drawing a random number between 1 and 10, and event B is drawing a random number between 50 and 100. So on 13, we want to find the probability of picking a 7 and picking a number greater than 88. So because it says and, we're going to multiply. So the probability of picking 7 and greater than 88. So of our numbers 1 through 10, only one of them is a 7, so that's 1 out of 10 times, and then all of the numbers greater than 88 in event B, there are 12 of them, and if there are a total of 51 numbers between 50 and 100, so we have 1/10 times 12 out of 51, which when we multiply gives us 2 out of 85. The last problem says find the probability of picking a single digit number or picking a 70. So the probability of single digit or 70. So of my numbers 1 through 10, 9 of them are a single digit, plus out of our 51 numbers on our second group, only one of them is a 70. But then we have to subtract the probability that when I draw from each event, I get a single digit and I get a 70. So I have to multiply my two probabilities together, which is 3 over 170, so 9/10 times 1 over 51. And when I do the math in a calculator, we're going to get 46 out of 51. So there's actually a pretty good probability that if I pick one number from each event, I'm going to get either a single digit or a 70, which makes sense that probability is going to be pretty high since so many of our values from event A are single digits, because 9 out of 10 of them are. Please, if you have any questions over anything from Module 8, you get in contact with me before you take the Module 8 test. And make sure you have Desmos and that Desmos Scientific Calculator open in each window as you're taking the test, so you can use the calculator function. There is a button that allows you to convert the decimal answers to fractions on that Desmos Scientific Calculator. So make sure you're using that, as the test will have fractional answers as the solution on any multiple choice questions.